Hello everyone, now let's talk about the homework number 5, the problem number 1. First, we are told that x and y are independent with the density function of x equal to this and the density function of y equal to this. And it also tells us that z equal to x plus y, so we need to find the density function of z by two methods. First is the convolution method and the second is geometric method. First, let's find the density function of z by convolution method. The convolution method, I think let's calculate this. Let's calculate this by let's calculate this first with this. The density function of x equals to this. This is the true density function of x. Shift to the right side. Shift to the left side by 1. The result is this, and the density function of y equal to this. In the next question, we will also find the density function of z by this first. First, let's see the convolution method is the density function of z equals to this is the definition. Also the definition. Then this equals to, let's see, this equals to we just multiply this one and this one together. And this equals to it's a very long expression. Very long expression, like, oh my gosh. And okay, then we have this equals to this one equals to since we know that the density function of x and the density function of y, it's all like to step function, they multiply together. So we know that, like, I mean, for this one, the step function, it's all 0 when the a is smaller than 1, and for this function, the value of this function, this step function, should be zero, should be all zero when a is larger than z minus 1. So we should only calculate the value of this in the interval 1 to z plus 1. So this equals to, let me see, finally equals to next to this. So this is the density function of z when the density function of x equals to this and the density function of y equals to this. Then we have to shift this to the right side by 1. So the final result is the true density function of z equals to z minus 1 times step function z minus 1 minus 2 times z minus 2 times step function z minus 2 plus z minus 3 times step function z minus 3. So it's the final result of the density function of z. And then let's talk about question 2. We need to find out the density function of z by geometric approach. Now let's see. We still have to calculate the density function for density function of x equals to density function of y equals to, so here the density function of x has been shifted to the left side by 1, so when we get the result of the density function of z, we should shift it to the right side by 1. So first let's see that since we know that the distribution function of z equals to the probability that z smaller than z, this equals to, since z equals to x plus y, we have this. And first let's see, if z is smaller and equal than 1, we have this curve. This figure shows that This line is x plus y equals to z. So this region should represent what means x plus y smaller than z, which is what we need to find out. So now we need to find out the area of this region. It's a triangle, so this region should be equals to z times z over 2 should be z to the power 2 over 2. So the distribution function should be this. Second, let's see that for the region z over 1 and smaller and equal to 2, in this region we have the figure. Like this. Oh, sorry, it's not so straight. So this line still represents x plus y equals to z, and this region represents also x plus y smaller than z. So we need to figure out the area of this region. This region equals to the area of this region equals to this big triangle minus 2 of this the smaller triangle. So it should be this equals to this. I'm sorry, I forgot to calculate the density function. The density function here is, let's see, here is this equals to z, and the density function here, here's a distribution function equals to this one, and density function equals to this. And last we have for z over than 2, since we know that the distribution function is apparently equals to this, and obviously it equals to 1, so we have the density function should be equal to 0, and we can draw the figure of the density function of z like this one. So this. So from this figure we can figure out that the density function equals to equals to this. But don't forget, we need to shift this to the right side by 1. So the density function of z equals to z minus 1 times step function z minus 1 minus 2 times z minus 2 times the step function z minus 2 and plus z minus 3 times step function z minus 3. So this is just the same as what we get from the first question, so let's see it is correct. So this is the resolution of the problem, the homework number 5, problem number 1. So thank you very much.